Hello and welcome back to another lecture from organic chemistry. In the last lecture, I was talking about how to produce primary amine, and the method that we went after it was sodium azide method. And I said we have three methods. We can practice them. Sodium azide method, or next one, it can be the Gabriel method or the reductive amination. Anyone that you use, you can get a primary amine, and the primary amine can be used again for any of these methods to produce a secondary or tertiary amines. Okay, so let's go after the Gabriel method. In Gabriel method, we have phthalamide, we treated with a strong base. The strong base is going to generate nitrogen with a negative charge. Nitrogen already has a lone pair, so here you go, we have a lone pair. We get another lone pair, that means we have a -1 charge. And because it has a negative charge, it will be a strong nucleophile or strong base. Okay, now, and this base or nucleophile, it can get involved in the SN2 reaction, and it will kick the leaving group out of the system through SN2 reaction. So next step, we will deduce alkyl halide, and we will mix it with potassium phthalamide, and that's going to give us this product. So R, it will be attached to nitrogen. Nitrogen has a lone pair plus X. So X took those two electrons and left the system as a leaving group. So that's going to be our leaving group. And third step, or last step of the mechanism, and we're going to technically hydrolyze the final intermediate, and we can do it through the acidic solution. If we use acidic solution, and this group, it will leave the system as NR, but because it's acidic, 3 hydrogens will be attached to nitrogen. So technically, we get a salt. And if we want to turn it to amine, we need to remove one of the hydrogens by a basic solution. That's one. And now any carbonyl group will be attached to OH, and it will give us a carboxylic group. So now we got the 2 carboxylic group by treating technically the phthalamide with acidic solution. Now, if we instead of if we use like neutral condition instead of acidic one, for your knowledge, the first method, they handle it when the pH is around 3 to 4, so that means acidic. The second one is technically the neutral method. If you use the neutral method, you will have 2 nitrogens attached to each other, and those 2 nitrogen attached to 2 carbonyl groups. Each nitrogen will be attached to 1 hydrogen. So out of 4 hydrogen, we used only 2 of them. Now, what will happen with the rest of the hydrogens? The NR, again, it will leave the system, but then we will have 2 hydrogens attached to it. And that's going to give us a primary amine. And the nice thing with the basic, the neutral method, or the second method, I call this one the second method, and that one call it first method. The second method, it will give you primary amine straight. Only thing that you need to do, you have to separate it from the side product. Now, the last method that I want to practice, it will be the reductive amination. You take a ketone or aldehyde, and you will treat it with NH3, presence of, say, C in an acidic solution. So first step, we added an acid, a weak acid. We activated the carbonyl group. And next step, this is going to happen. So say we have this. We're going to introduce H, and if we add H, we will get this compound. Oxygen has a positive charge. Because it has a positive charge, it's not going to be happy. So this is going to happen. Oxygen is going to try to steal those 2 electrons and it will leave carbon with a positive charge. And if this one happen, we get such a thing. positive charge here. Next step, NH3, it can get involved and it will attack technically that carbon, and we get such a compound. Say, or I can put this one here. Now, our nitrogen, it has a positive charge. If I remove water from this system, okay, how? Take, for example, this one, OH, plus an H, also from NH, that's going to leave me with this compound. Something like that. And of course, here I have a positive charge. And again, this one can get involved and turn to something like that. So say minus H plus. So finally, I get this, which is the amine compound. Now, this, it can be reduced through reduction process and turn it to a primary amine. Because I used ammonia, I can turn it to a primary amine. So the final product, I'm going to write it here. It will be something like this. And so it's going to be carbon, and then we get NH. And of course, we have hydrogen here, and this one will be a primary amine. Okay. Now, one last step. Okay, last step, I can use some specific reducing agent, something like sodium cyanoborohydride. The nice thing with this compound is that it's not going to react with ketone or aldehyde. So that means I can mix everything from the beginning and, wait until NH3 or NH2 react with the ketone. And then next step, the cyanide active reducing agent is going to get involved. So I don't need to be worried that I'm reducing the carbonyl group and from the beginning. That's not going to happen. Well, with lithium borohydride or sodium borohydride, they can reduce the ketone to alcohol and stop actually the reaction. And so we're not going to get a technically amine compound. So if we use NH3, this is going to happen. We will get N attached to carbon through a double bond, and now we will have a lone pair there. And if we reduce it by, sodium cyanoborohydride, one of this hydride will be given to that carbon, and technically we get NH, and then H here, and the carbon will be saturated. I don't need to show them like hydrogen and carbon. Now, where did I get this hydrogen? That hydrogen, I got it from acidic solution like H2O. So, and I need, like a treat the solution or the product with acidic solution and until I turn technically amine to the amine to amine. And this one, it will be a primary. So this one is going to be amine. That's amine. Okay. And if you replace ammonia by primary amine, okay, in that case, you will have N attached to R. Okay, yes, we have a lone pair again there. And now I go N attached to R. And there will be one hydrogen also attached to it, and we will have lone pair. This is going to be a secondary. And if I use a secondary in the amine, I will get this nitrogen attached to R, another R. This nitrogen, it will have a positive charge, because now we have a positive charge. If we use reducing agent plus acidic solution like H2O, I will get this. I get N attached to two R's Okay, and we had alkyl group from the beginning. Okay, so nitrogen was attached to carbon through a double bond. So now our nitrogen is attached to three carbons, and that's going to give us a tertiary amine. Okay, so as you see, it depends what you start with. If you start with ammonia, you get a primary. If you start with primary amine, you get secondary amine. And if you start with a secondary, okay, with a secondary amine, you get tertiary. So you start with ammonia, you get a primary. Start with the primary amine, you get a secondary amine. And if you start with the secondary amine, you get a tertiary amine. Always one technical unit, you go up your primary, your amine will be 1 unit higher than the starting compound. And this is going to be end of this lecture, and thank you very much.